take a look at solving linear systems by graphing. So a linear system, that's what this is. A linear system is when we have two linear equations and we're trying to figure out where they're intersecting, right? What this coordinate is going to be, so what's the x value and the y value of where the two lines cross, okay? So each of these equations represents a line. So I'm going to refer back to our parent function, you could call it, y equals mx plus b. And what this will do is, if you recall, the variable or the value for m and the variable or the value for b, whatever those are, they're going to tell us specific points on a graph. Okay, your m is equal to the slope of the line, which is also known as the rise over the run. Okay, and your b value is the y-intercept. So I'll call it y-intercept. Okay, so y-intercept is always a pretty good place to start. Let's take a look at our equation below. What value or what number represents b in this equation?
-1.
-1, great. Okay, so y-intercept, we're looking at the y-axis, so that's the one going up and down like a yo-yo. We'll find where -1 is. Well, -1 is right here at this point, right? Okay, from there, so now that we have our y-intercept, we now apply the concept of slope, the rise over the run. Well, luckily, this is a fraction already. So rise is the numerator, so that's the top. So we go up 2 values because technically it's +2. Okay, and then run is our denominator, 3. So we go horizontal, 3. So in a positive direction, 3. So we're going to start again at here. We said our rise was 2, so we go up 1, 2. We don't stop there. We then apply our run. We go over 1, 2, 3. So here is our next coordinate, or our next point. Okay, and it doesn't matter actually if we decide to do run first and then rise. It doesn't make a difference. So if I go run 1, 2, 3 and rise 1, 2, we're still going to stay on the same thing. We're just used to writing it rise over run. Okay. Now if you notice, I always did the positive direction. I'm going to show you a little trick here. This has to do with dividing fractions. Okay. 2 over 3 is actually equal to -2 over -3. The reason being is because if you remember your integer rules, a positive divided by a positive is a positive. And that's right, this is a positive value. And a negative divided by a negative, do you know what that's going to be?
Negative.
There it is. Actually, it's going to be a positive. So
Well,
that's
yeah.
why these are equivalent.
Yeah, if
Right?
they're the same, they equal positive.
Yeah, exactly. So because this is a negative divided by a negative, it's still going to be a positive value. So why did I show you that idea? Well, I showed you that idea because what that means is from our y-intercept, I could have had a rise of -2 and a run of -3. Okay, so what does that mean? A rise of -2 is actually to go down 2, 1, 2. And to run 3, or -3 would be going backwards, 1, 2, 3. Here's our next coordinate. Okay? And if you look at our line, and I'm just going to do a rough sketch and then I'm going to actually put a line in here, that falls directly in line with what we're drawing. If we go back that direction, I kind of missed it there. But that's perfect. That actually works out great. So that's why I showed you that concept. You could actually go either way. So now I'm going to take a line, and I'm going to just connect our dots here. Hopefully I do a pretty good job. There's our line, and you can continue it forward. It continues farther from this, so I'm going to put the little 2 arrows on the end. It kind of goes infinitely. Let's go to our other value here. Okay, so let's take a look at our other one. We have y is equal to mx plus b. I don't know if the blue just didn't write in there. That was weird. Okay, what's my b value in this equation?
4.
4, perfect. So when we go to the y-axis, we go to the value of 4. I'll use a different color this time. Here's our 4. What's my slope in this one? Or my m value, actually. Let's start with that.
-1 over 1.
Perfect. You're right. That's 1. And you can make any whole number a fraction by just putting it over 1. So what do I rise and what do I run?
The rise is -1.
Yep.
And the run is 1.
Perfect. So we go down 1 and then over 1. I know that didn't look perfect, but let's get our red in here. So that would be this spot here. Down 1, over 1. Down 1, over 1. Here we go. So I would continue that pattern until I've crossed the other line. In fact, I can extend it, right? And go a little farther. Down 1, over 1. Down 1, over 1. And then we get, I'll make this line red. we have our point of intersection. So now we kind of play like a game of bingo. We got this point. What is this point on the graph?
3, 2.
That's perfect. 3 and then 2. So that coordinate is 3, 2. So by graphing, we've now solved this. The point of intersection for this linear system is 3, 2. There are other ways to do this. We could have done substitution or elimination, and those might be good ways to check because graphing can become a little inaccurate sometimes. Sometimes if you have an answer that's a decimal or fraction, it's really hard to see on a graph. This one worked out nicely. They're two whole numbers. But if you were to draw a graph and you got, I'll give you an example again. Let's say we had a point of intersection that was kind of like there. I don't really know where that is. It might be halfway. It might not. My graph isn't detailed enough to tell. That's when I would use other methods where I'd use like elimination or substitution to solve it. Okay?